8.7, we're doing polar equations and graphs, and it's kind of like when we deal with rectangular, when we deal with polar, it's kind of like that's two sides of the same coin. I realize we are very comfortable with rectangular. If I gave you the point 3, 5, I think everybody in here would know to go right 3 and up 5, and that's where that point would be. Okay, we're good at that because we've spent years talking about the rectangular coordinate system, x and y. But polar is just the other side of the same coin. We're still describing some place, okay? So if I gave you like 5, 45 degrees, that's just describing a point in the plane somewhere, okay? I guess the main difference is you want to find the angle first. Imagine if somebody told you to walk a mile north. You don't just start walking the mile. You'd have to point yourself in the northerly direction first, find the direction first, and then walk a mile. So when you're looking at a point in polar coordinates, you're going to want to find the angle first, 45 degrees first, and then go 5 in that direction. That's how it's going to work, though. One of the things we'll have to do is convert back and forth, and you should be familiar with this because we've done it the past 3 or 4 lessons. So we use these formulas. Now notice I added this extra one. Actually, this is the one we're probably more used to, and we might need to use the cousin of this. These two are cousins. But look at these 5 formulas. These 5 formulas are ones we would use to go back and forth. Those should look familiar to you. Example 1, we're going to plot some points. It says plot each point by hand, then determine the rectangular coordinates of each point. So in order to plot this by hand, it's really pretty simple. Start with 30 degrees, though. Now, it would be nice if they labeled it, but they didn't label. This is 0 degrees, and we know this is 90 degrees. It turns out that every one of these marks goes by 15. So that's 15, 30, 45, 60, 75. We could go all the way around the circle if we want. I don't really want to, though, because I don't need to, because we're looking at 30 degrees. And so the first thing you would do is find the mark that coincides with 30 degrees, and then go 2 units in that direction. So did you find the mark that corresponds with the 30? Start from the origin, and go 2 in that direction. 1, 2, there'd be a point right there. So 30 degree direction, 2 units in that direction. That is point P. So let's label that point P. That's all there is to it for graphing. But then notice it says to determine the rectangular coordinates. Anytime they say that, they're talking about x and y. And we know how to do this because we've done it the last couple of sections. If I want to find the x part, I'll take 2 cosine 30 degrees. So use the chart. Cosine 30 is what? Square root of 3 over 2. Good. So we have 2 times square root of 3 over 2 is just square root of 3. That's the x part. And then if I want to find the y part, it's going to be 2 sine 30. Yes. What's sine 30? 1/2. Very good. 2 times 1/2 is 1. And that's your y coordinate. So if we were writing the rectangular coordinates, you could write it as a point, I suppose, square root of 3, 1. Or you could write it as a vector like we did in the last section, square root of 3 plus I, one way or the other. Either way, that's describing the same location. (1b), you've got another pair of points, but this one's in polar form. I mean in radians. Okay, it's polar form, but it's in radians. And so here's 0 and here's pi over 2. I always start with that. Now, one thing to keep in mind, or one thing to know, I guess, is 15 degrees is the same thing as pi over 12. So every one of those marks is 15 degrees, it's pi over 12. So this is pi over 12. 2 pi over 12 reduces to pi over 6. And 3 pi over 12 reduces to pi over 4. And 4 pi over 12 reduces to pi over 3. And 5 pi over 12 doesn't reduce. And then 6 pi over 12 is pi over 2. And so I'd probably start with that in radians. Now notice we have to go to 2 pi over 3. So really we could keep going, another pi over 12, another pi over 12, another pi over 12. Or here's a shortcut. See how this is pi over 3? Here we go, 1, 2, 3, 4 marks is pi over 3. So 1, 2, 3, 4 more marks will be another pi over 3. And so 4 more marks is where 2 pi over 3 would be. I don't have to label everything. I just need to find where 2 pi over 3 would be. And that's the direction of 2 pi over 3. Now, notice this negative 4. This negative 4 just means the opposite direction. Okay? The opposite direction. And so really what we would do is we would identify the direction of 2 pi over 3, but we would go in the opposite direction. So count off 4 in the opposite direction, and that's where point Q would be. Now I'm going to skip the conversion. Well, let's do the conversion. The x would be negative 4 cosine 2 pi over 3. And so in order to do cosine 2 pi over 3, look at its reference. It's a cosine pi over 3, but it's in the second quadrant. Cosine pi over 3 is 1/2. In the second quadrant, that makes it negative. So we've got negative 4 times negative 1/2 is positive 2. And then when we do y equals negative 4 sine 2 pi over 3. Sine 2 pi over 3 is like sine pi over 3 in the second quadrant. So sine pi over 3 is square root of 3 over 2. In the second quadrant, it's still going to be positive. So negative 4 times square root of 3 over 2, that's negative 2 square root of 3. Negative 2 square root of 3. So your rectangular coordinate is going to look like 2 comma negative 2 square root of 3. Part C, we've got 5 comma negative pi over 4. So pi over 4 is up here. That's like 45 degrees. Negative pi over 4 must be down here. So again, start with the angle. Start with that direction. Negative pi over 4, and then go 5 units in that direction. So 1, 2, 3, 4, 5. Puts us right there. That's point R. I'm going to skip the conversion on this. Now, notice one thing that makes this, I don't know if it makes it harder or easier, but basically there's an infinite number of equivalent points in polar form. If I'm in rectangular and we go over 3 and up 5, that's it. That's the only way to represent a point in rectangular. But in polar form, you think about it, all I'd have to do is add 360 degrees and I'd be right back at the same place. Add 360, add 360, add 360. There are going to be an infinite number of different ways of representing a point in polar form.